Bright Tuty. Every student matters.
Hello students, my name is Sanjay Jain. In this exercise we will do the questions based on volumes of combinations of solids, right. So let us start with an example here so that we understand this topic better. There is this shed. Shanta runs an industry in this shed which is in the shape of a cuboid surmounted by a half cylinder. So there is a cuboid, this one, the base shape, and then it is surmounted by half cylinder, right. Let us say this is cuboid, okay. If you look at the only the front portion, right, and it is surmounted by a cylindrical, half cylindrical shape, okay. So let us make this cuboid here, and it is surmounted by a cylindrical shape, right. So this completes this shed. Now what will be the volume of this shed? We need to calculate the volume of air that this shed can hold. So whatever the capacity of this shed is, we need to calculate. What is the capacity? It is the combination of volume of this cuboid and this half cylinder, right. This is the space where this air can come, okay. If I talk about this room here, it is of cuboidal shape. If you ask me what is the volume of air that this room can hold, I will calculate the volume of this cuboidal shape or this volume of cuboid. Now there is a shed of cylindrical shape, right, of half the equal to the half of cylinder. So I need to add that volume, okay. So if you talk about this question, volume of air that this shed can hold, it will be volume of air the shed can hold is equal to volume of cuboid plus volume of half cylinder. Now we are already given the dimensions. What are the dimensions? For cuboid, dimensions are 8 meter, 7 meter and 15 meter. So volume of cuboid is 8 into 7 into 15 plus volume of half cylinder. So it will be half of pi r square h. What is the radius? Radius will be half of 7, right. So r square into h, h is 15. Just look at this top portion, it is half cylindrical. I am talking about this length, this is acting as the diameter of the cylindrical shape. So half of it will be radius, which is 7 by 2, and what is its height of the cylinder? It is equal to this edge here, this one, right, and it is 15 meter. So the volume is half pi 7 by 2 squared into h, which is 15. So this is the volume of air that the shed can hold, okay. So this is 56 into 15 plus half of 22 by 7 into 7 by 2 into 7 by 2 into 15. So this 7 gets cancelled, 11. This will give you 84. So 840 comes from here, and from this side 11 into 7 is 77 into 15 by 4, okay. So 840 plus this will be 1155 divided by 4. So if I want to convert it into decimals, 288.8 is the decimal conversion. Now we are talking about volume here, and the units are in meters, okay. So this will be in meter cubed, right. You just need to add these. So 0.8, 8 plus 0 is 8, 8 plus 4 is 12, 3 plus 8 is 11. So this much volume this entire shed can hold inside it. Now another question is there. Furthermore, suppose the machinery in this shed occupies a total space of 300 meter cube. So there is machinery inside this shed, right? And there are 20 workers. So there are 20 workers inside it, each of whom occupy about 0.08 meter cube space on an average. So how much air is in the shed? So how much air in actual is inside the shed? We need to subtract the volume of machinery and volume of people inside it from this volume, right? So what is the volume of machinery? It is already given 300 meter cube. Volume of 20 workers will be 20 into volume of 1 worker. So volume of 20 workers, or we can say the space occupied, by 20 workers, okay, is equal to 20 into 0.08, right? So it is equal to 1.6 meter cubed, right? Now volume of air inside the shed is equal to 1128.8 minus 300 for the machinery minus 1.6 for the people inside it, okay. So 1128 minus 300 is 828.8 minus 1.6. This you need to subtract carefully. So this will give you 2, this will give you 7 here. 827.2 meter cubed is the volume of air inside the shed with the machinery and people inside it, okay. Now this is an interesting question. There is a juice seller who is serving his customers using glasses, right? And the glass on the outside looks like this, right? The customer will think that he is getting the juice full of glass full of juice, right? But the trick is that the glass is of the shape this bottom of this glass, there is a hemispherical shape inside it. So if you fill it with juice, apparently it will look like a glass full of juice, but this much volume is lesser inside it, right? So if you talk about the volume of the juice inside this glass, you'll have to subtract this volume. What is this shape? This is hemispherical shape, right? So let us look at the question again. The inner diameter of the cylindrical glass was 5 centimeter. So this was 5 centimeter. Inner diameter. So this is 5 by 2 centimeter. I am talking about radius here. So it is half of the diameter, 5 by 2 centimeter. But the bottom of glass had a hemispherical raised portion which reduced the capacity of the glass. If the height of the glass was 10 centimeter, so this is 10 centimeter. The apparent capacity of the glass and its actual capacity. Apparent capacity is what looks from the outside, right? A customer will think that he is getting juice, volume of juice equal to the volume of glass, right, which looks from outside. So apparent capacity is the capacity of cylindrical container without the hemispherical bottom, okay. So it is equal to pi radius squared, which is 5 by 2 squared, into height, which is 10, right. So this is the apparent capacity, 22 by 7 into 5 by 2 into 5 by 2 into 10, okay. This capacity is in centimeter cubed, right. So this will give you, or what we can do is, this is 5 into 5 is 25, so 250 by 4 into, this is approximately 3.14, right. So let's multiply 250 with 3.14, then we will proceed ahead. After that we will divide by 4, right? So this will give you or we can add 0 later, right? You do this calculation yourself. So this, when 78500 and you put decimal here, divided by 4 centimeter cubed is the apparent capacity, right? What is apparent capacity? Which I think I am getting, okay, which looks like, which is evident, right? If I look at this glass from outside, I'll think that I am getting this glass full of water. But if there is hemispherical bottom, I need to consider it, right? When I finish the juice, I'll see the bottom, right? There was a hemispherical bottom. So I need to subtract that to calculate the actual capacity. So this is 785 by 4 centimeter cubed. If you want to convert it into decimal form, you can do that also. So this much is the apparent capacity. Actual capacity will be lesser. And how much lesser? It will be lesser by the volume of this hemispherical bottom, okay. So actual capacity will be 196.25 minus volume of hemisphere, right. So what are the units of hemisphere? What are the dimensions of this hemisphere? The radius of this hemisphere is also 5 by 2 centimeter, right. So volume of hemisphere is 2 by 3 pi r cube. R is 5 by 2 cubed, okay. Now you can calculate it separately and subtract from 196.25 to calculate the actual capacity. So let's calculate it here. 2 by 3 into, let us consider it 3.14 into, this is 125 divided by 8, okay. So this is 4, 125 into 3.14, 125 into 3.14 divided by 12, okay. So you can do this calculation like this. So this is 392.5, okay, divided by 12, okay. So what we can do is 196.25 minus 392.5 divided by 12, okay. I am not wasting any more time in calculations. You can do this calculation yourself, but don't forget the unit centimeter cubed in the end. So this is the apparent volume, and when you subtract this volume of the hemispherical bottom, you will get the actual volume, right. So this is how we will go about this question. A solid toy is in the form of a hemisphere surmounted by a right circular cone. The height of the cone is 2 centimeter, diameter of the base is 4 centimeter. So there is a hemisphere, it is surmounted by a cone, okay. The height of the cone is 2 centimeter, so this is 2 centimeter, and diameter of the base is 4 centimeter. So the radius here is 2 centimeter, okay. So this gave me the dimensions of the hemisphere also. The radius of the hemisphere is 2 centimeter. Determine the volume of the toy. So we can clearly see the volume of the toy will be sum of volume of this hemispherical portion and the volume of the conical portion. So volume of toy is volume of hemispherical portion. It is 2 by 3 pi r cubed, so 2 cubed, plus volume of the conical portion, it is 1 by 3 pi r square, so 2 square into h, which is again 2, right. So this is the volume of the toy in centimeter cube. So what we can do is, this is 8 into 2 16, so 16 by 3 pi, plus this is 8, so 8 by 3 pi, so it is effectively 24 by 3 pi. Okay. So this is the volume of toy in centimeter cubed. Now you can take the value of pi as per the given instructions as 22 by 7 or 3.14 to do the further calculation. Okay, I am leaving it to this 24 by 3 pi centimeter cube. Now there is another part of this question which says, if the right circular cylinder circumscribes this toy, find the difference of volumes of cylinder and toy. So there is a cylinder which circumscribes it. By circumscribing, it means it is touching the toy from every side, right? It is touching exactly this toy, right? This means circumscribing this toy. Okay. Otherwise, you can take a bigger cylinder also, but no, you have to take this size of the cylinder. So this is the cylinder that has circumscribed this toy. Now the dimensions of this cylinder can be calculated by looking at the toy itself. Look at the toy. This was 2 centimeter and this was also 2 centimeter, because this is the radius or the dimension of the hemisphere is 2 centimeters. So this will also be 2 centimeter, right. So what is the height of the cylinder? It is 4 centimeter, right. And what is the radius of the cylinder? It is 2 centimeter again. It is 2 centimeter. So volume of cylinder is equal to pi r square. R is 2, so 2 square into h. H is 4. So it is equal to 4 into 4, 16 pi, right. And we need to find the difference of volumes. So difference is equal to volume of cylinder, which is 16 pi, minus volume of toy, which is 24 by 3 pi, right. So what is the exact difference? If I want to simplify it further, I can write it 48 pi minus 24 pi divided by 3. So it is equal to 24 pi by 3 centimeter cubed, and it is equal to the volume of this toy. So volume wise, there can be 2 toys that can fit into this cylinder, right. I am talking about volume wise. If you melt those toys and convert it into cylinder, it will be exactly this cylinder which is circumscribing this toy, right. So this is the difference.